Hi, everyone. I wanted to do a quick video on the unit circle. We typically have been adding a little bit to the unit circle as we go, a little bit every day. So I wanted to make a video just about how we fill out all of the sines, cosines, tangents, degrees, and radians for each of these points on the unit circle. So here we go. I'm going to use some of the knowledge we've already talked about in class, starting with degrees. We're going to fill in all the degrees. So I know that this is 0 degrees. I do. And I know that it's also 360 degrees if we went all the way around the circle. And we've said that halfway around the circle, if you do like a half jump on skis or snowboard, 180 degrees. So 0, 180, 360. And then the other two we usually fill in right off the bat are 90 degrees, because that's halfway between 0 and 180, and then 270 degrees down here. So those are the quadrantal angles. They end up right on those quadrant lines, 0, 90, 180, 270, 360. Each quarter of a circle is 90 degrees. Now, as we've seen in this chapter, special right triangles are a big deal. On the unit circle, we know that. So I know that these three angles are my special right triangle angles, 30, 45, and 60 degrees. Okay, 30, 45, 60. So anytime you see a sort of a big gap on the unit circle, it's an increment of 30 degrees. And then these two smaller ones are each 15. And using that pattern, we can go around. We can say, okay, big gap, so add 30 to 90, we get 120. Small gap, so 135. Small gap, so 150. Big gap would take us to 180, so feeling good. Big gap, 210. Small gap, 225. Small gap, 240. Big gap to 270, so that makes sense. Each big gap is 30. So another big gap, 300, small gap, 315, small gap, 330, ending at 360. And just like that, we have our entire unit circle filled out in terms of degrees. Let's talk radians. 0 radians, and I know a full circle is 2 pi radians. I also know that half a circle then is 1 pi radians, so just pi. And so as for those other quadrantal angles, this is pi over 2 because it's halfway between 0 and 1 pi, so half a pi. And this is 3 pi's over 2, 1.5 pi's, which is right in the middle of 1 pi and 2 pi's. So what about those inside ones? Here's how I like to think of it. I like to start with my 30 degrees. And the key to this is knowing that every 30 degrees is pi over 6. Because 30 is 1/6 of 180. So pi over 6 is 1/6 of pi. So every 30 is pi over 6. Well, that means that 60 degrees is 2 pi over 6. Except, I don't want to leave it like that. I'm going to simplify my fraction. 2 pi over 6, let's just call this pi over 3. My next 30 degrees would get me here, 3 pi over 6, which is already simplified, pi over 2. So then 4 pi over 6, which would be 2 pi over 3, simplifying. 5 pi over 6 if we go 30 degrees more, so that's just 5 pi over 6. And then that gets us to 6 pi over 6, which is just pi. So it seems like it's working out. Let's do the same on the bottom half. So 7 pi over 6 doesn't simplify. 8 pi over 6 would be 4 pi over 3. 9 pi over 6, yep, that works out there. 10 pi over 6 is 5 pi over 3. 11 pi over 6 is just 11 pi over 6. And 12 pi over 6 would be 2 pi. So with that in mind, all we have left are those 45s, those ones in the middle of the quadrants. Every 45 degrees is a pi over 4. 1/4 of pi. So pi over 4. Here's my next 45 degrees. That would be 2 pi over 4, which simplifies, so we're looking good. 3 pi over 4. 4 pi over 4, yep, that works out. 5 pi over 4, 6 pi over 4 simplifies, 7 pi over 4, and then 8 pi over 4 is my 2 pi. So with those kind of logical steps, and I'm hoping they made sense to you, we've got all the degrees, we've got all the radians. So now it comes time for sines and cosines, and here's kind of the key for this. Remember that sine of theta is just its y value, and cosine of theta is just the point's x value. So if we list out those points, the coordinates, we essentially have listed our cosine comma sine values because we'll do x comma y. Unit circle, I know that the radius is 0. That doesn't make any sense. The radius is 1. I was about to write 0. So the radius is 1 in the unit circle. That point then is 1 comma 0 because I went out to the right 1 in the x direction. I didn't go up or down at all, 1 comma 0. This is 0 comma 1. Now I'm going to the left, so negative 1 comma 0 and 0 comma negative 1. So we've got that going. I'm just going to focus in on this first quadrant now. This first quadrant is all we really need to learn, memorize, whatever you want to say. So first, I'm going to look at this nice 30, 60, 90 triangle here I have. It's a special right triangle, and we know something about special right triangles. We know that the longer leg is x root 3, and the shorter leg is just x. The hypotenuse is 2x. Well, I'll draw it over here. We know the radius is 1, we just said. That means the shorter leg is half of that, so 1/2. The longer leg is root 3 over 2. That means anytime I have a 30, 60, 90 triangle and I see a long leg, I know it'll be root 3 over 2. And I know the short leg will be 1/2. Those are the coordinates of that point. Well, then what about this 30, 60, 90 triangle? Still a 60, 30, 90 triangle. The longer leg is up. So that means the short leg is the x, 1/2. And the long leg is the y, root 3 over 2. Using that, we can fill in a bunch of the other ones around the circle. But before we go there, I want to talk about my 45, 45, 90 triangle. That doesn't look good at all. 45, 45, 90, doesn't look great, but I'll go with it. 45, 45, 90. If you remember, these two legs are always root 2 over 2. And so for a 45-degree angle, those legs are the same. We went out in the x direction, root 2 over 2. We went up in the y direction, root 2 over 2. If you understand and memorize this first quadrant, you are set. Because let's look across the circle into quadrant 2. I'm going to make the claim that the coordinates here are negative 1/2 root 3 over 2. And how did I know that? It's a 30, 60, 90 triangle on the other side. Short leg in the x direction, so negative 1/2 because I'm going to the left. Long leg going up, so positive root 3 over 2. And you'll notice it's also just that point, that set of coordinates reflected. The x became negative. That will continue on. Root 2 over 2, root 2 over 2, because it's just reflected from the first quadrant, but my x became negative. Here I'm going a long way out in the x direction to the left. That must be my negative root 3 over 2, but I'm still going up the short leg, up 1/2. Let's reflect down and let's think about those long leg, short leg. So long leg out to the left, negative root 3 over 2, and then short leg down, negative 1/2. This is my medium leg for the 45. So negative root 2 over 2 because I went left, negative root 2 over 2 because I went down, negative 1/2 because I went left, the short leg, negative root 3 over 2 because I went down long, And then again, if you're visualizing these, I went right, so it'll be positive, but it's the short leg, so 1/2, but then down the long leg, negative root 3 over 2. Right here, I went right the medium amount, so root 2 over 2, and then down the medium amount, negative root 2 over 2. And then I went the long leg out, so positive root 3 over 2 in the x direction, and down negative 1/2 in the y. And just like that, we've got a really beautiful unit circle here. We've got the degrees, we've got the radians, we've actually got sines and cosines in the form of those points. Another way you'll sometimes see it written is that x comma y equals cosine theta sine theta. X is the cosine, sine is the y. Now there's one other thing that I want to put on my unit circle, and that is the tangent values. I'll do these in green. So we know that tan of theta equals y over x. Start with your quadrantal angles. Y over x at 0 degrees, 0 over 1 is just 0. 90 degrees, 1 over 0 up here. If you remember, that's undefined. Tangent there is undefined because we can't divide by 0. 0 over negative 1, so that's just 0. Negative 1 over 0, so that's undefined because we can't divide by 0. The next tangent values I love are those 45s, those ones in the middle of the quadrants, because anytime y and x are the same, what's something over itself? Y over x, root 2 over 2, over root 2 over 2. Tangent is just 1. Maybe negative 1 because one of those is positive, one of those is negative. Now they're both negative, so negative divided by negative will be a 1. And y over x, that'll be a negative 1 over here for my tangent values. So those 8, we've got 8 tangents on there. We have 8 to go. Here's what I would do. I come over here and I'm looking at pi over 6. I'm looking at 30 and I say, okay, so y over x is 1/2 over root 3 over 2. So copy dot flip, I know to do that, 2 over root 3. So 1 over root 3, but I don't want that radical on bottom, so multiply by root 3 over root 3, and we get root 3 over 3. Y over x gives me root 3 over 3 here. Now, if you reflect this point, that will be the same tan value everywhere else, other than a possible positive negative. I flip it over here, it's going to be negative root 3 over 3. I know it's negative because one of those y, x values, one of them was positive, one of them was negative. And a positive divided by a negative is a negative. Let's flip down 30 degrees, and I see it's going to be positive root 3 over 3. Because both of them are negative, negative divided by a negative is a positive. Flip it across to the fourth quadrant, negative root 3 over 3, because again, y's are negative, x's are positive. Divide them, we will get a negative number. And then there's only one other spot we need to look at that tan value and then reflect it everywhere. That's right here. Y over x, copy dot flip, we get root 3 over 1, or just root 3. So I know that this tan value is root 3. I know I can reflect it, and this one will be negative root 3 because one of those xy values was negative, one of them was positive. This one will be positive root 3 because they're both negative. They'll cancel each other out when we divide. This will be negative root 3. And by reflecting, we now have all the tangents to go along with all the sines and cosines and the coordinates and the degrees and radian angle measures. So we don't do unit circle all in one day because that's a lot. That's a lot that I've just put on the screen and talked about and thrown at you. This is why we do a little bit at a time, a little bit each time. But I'm hoping this helps. I'm hoping you're seeing those patterns and that given the work we have done with the unit circle already, this solidifies it. This gives you a nice, good method to fill this entire unit circle in in a quick, timely manner.